As the wheels touch down on Soviet soil, none of these American airmen realize they have just handed Joseph Stalin the most sophisticated military technology on the planet, including a radar system so advanced that Soviet engineers would later confess it could see through any night, any weather, any darkness that nature could conjure. This is the story of how a desperate emergency landing changed the Cold War before it even began. If you enjoy deep dives into military history, subscribe to this channel and comment where you are watching from right now. The Boeing B-29 Superfortress was not merely an airplane. It was a flying laboratory, a pressurized fortress bristling with technology that seemed to belong to science fiction rather than 1944. While the world focused on its ability to carry the atomic bomb, military engineers understood that the B-29's true revolution lay in its electronic systems. The bomber carried the AN/APQ-13 radar bombing system, a device that could paint the ground below in eerie green phosphorescence, revealing cities, rivers, coastlines, and industrial targets through complete cloud cover or the blackest night. For crews flying at 30,000 feet in the freezing darkness over Japan, this radar was the difference between blindly dropping bombs and precision strikes that could cripple an enemy's war production. The radar dome beneath the B-29's fuselage housed a rotating antenna that swept invisible radio waves across the earth below. Those waves bounced back from buildings, from water, from the contours of the land itself, and the radar interpreted those echoes into a navigable map. American bombardiers could identify a target factory complex from miles away, line up their approach, and release their payload with unprecedented accuracy for nighttime operations. The Japanese had no comparable technology, neither did the British, and certainly not the Soviets, whose radar development had been stunted by the German invasion and the desperate need to focus all industrial capacity on immediate survival rather than advanced research. The Soviets first became aware of the B-29 program through an unlikely source. In June 1943, Eddie Rickenbacker, America's most famous World War I ace, visited the Soviet Union on a diplomatic mission. During a friendly conversation, Rickenbacker mentioned to his Russian interpreter that America was developing a revolutionary, new heavy bomber. What Rickenbacker did not know was that his interpreter also worked for Soviet intelligence. Within hours, that casual remark had been transmitted to Moscow, and Soviet intelligence began assembling every scrap of information they could find about this mysterious new aircraft. But intelligence reports and grainy photographs could only reveal so much. The Soviets needed to see the actual machine. They needed to touch it, disassemble it, understand every rivet and wire that made it function. In the Byzantine world of wartime alliances, they formally requested 120 B-29s through the Lend-Lease program, the same arrangement that had already provided them with thousands of American trucks, tanks, and aircraft. Washington ignored the request entirely. The B-29 was too secret, too valuable, too advanced to share with an ally whose post-war intentions remained deeply uncertain to American strategic planners. Then, on July 29, 1944, the heavens delivered what diplomacy had denied. The B-29, named Ramp Tramp, serial number 42-6256, belonged to the 462nd Bomb Group. It had taken off from bases in China as part of Operation Matterhorn, the ambitious campaign to strike at Japan's industrial heart from Chinese staging areas. The mission had gone badly. Japanese fighters and anti-aircraft fire had savaged the formation, and Ramp Tramp emerged with damage too severe to make the long flight back to friendly territory. The crew faced a terrible choice: ditch in the ocean and hope for rescue, attempt a suicidal return flight, or divert to the Soviet Union, which was technically neutral in the Pacific War. They chose the Soviet Union. It seemed like the safest option. After all, the Soviets were allies against Germany. Surely they would refuel the aircraft and send the crew on their way. The wheels of Ramp Tramp had barely stopped rolling when Soviet military personnel surrounded the aircraft. The Americans were politely but firmly escorted away from their bomber. They would not see it again. Over the following months, 3 more B-29s would make similar emergency landings on Soviet territory. Each time the pattern repeated. The crews were interned, the aircraft were seized, and American diplomatic protests were met with bureaucratic stonewalling. The American airmen found themselves in a strange limbo. They were not prisoners of war, since the Soviet Union was not at war with Japan. They were not quite guests either. Soviet authorities moved them from camp to camp across Uzbekistan and Turkmenistan, keeping them isolated from the outside world while maintaining a thin fiction of hospitality. In reality, the men were hostages of a sort, their presence ensuring American discretion about what was happening to their aircraft. Eventually, the Soviets arranged a series of elaborate escapes. The airmen were smuggled across the border into Persia, into British-controlled territory, where they could be repatriated to America. These escapes were carefully orchestrated by the Soviet secret police, staged with such theatrical precision that few outside a small circle of intelligence officers knew the full story. Upon their release, the American crew members were asked not to publicize their experiences, ostensibly to protect escape routes for future prisoners. The real reason was simpler. Washington did not want to create an international incident with an ally it still needed in the war against Germany. While the American crews made their way home, their aircraft began a very different journey. The 3 flyable B-29s were transferred to the Ismailovo airfield outside Moscow and placed under the command of Air Marshal Alexander Golovanov. Soviet test pilots flew the bombers carefully, methodically, learning their handling characteristics, while teams of engineers swarmed over every accessible surface, photographing, measuring, cataloging. Joseph Stalin was simultaneously fascinated and infuriated. The B-29 represented everything the Soviet aviation industry had failed to produce. Soviet designer Andrei Tupolev had been working on a strategic bomber called Samolet-64, but the project was behind schedule and lacked the sophisticated bombing and navigation equipment that made the B-29 so effective. Stalin's rage at Soviet technological inferiority was legendary, and those who failed him often disappeared into the labor camps of the Gulag, or simply vanished entirely. Air Marshal Golovanov reportedly suggested a solution that was audacious in its simplicity: copy the B-29 exactly. Not adapt it, not improve upon it, not use it as inspiration for a Soviet design. Copy it, rivet for rivet, wire for wire, until Soviet factories could produce an identical aircraft. In June 1945, Stalin issued his orders. The Tupolev Design Bureau would reverse engineer the B-29 and put it into production within 2 years. The decree was extraordinarily detailed, placing the full weight of responsibility on Tupolev's shoulders while simultaneously commanding every branch of Soviet government and industry to support the effort with whatever resources he required. For Tupolev, the assignment carried a particular edge of terror. He had been arrested in 1937 on fabricated charges that he had sold aircraft designs to the Germans. He had spent years working in a Gulag-like prison design bureau before being released in 1941. He would not receive a full pardon until 1955, 2 years after Stalin was gone from the earth. Tupolev understood better than anyone that Stalin's 2-year deadline was not a target date. It was a death sentence if he failed. The reverse engineering process began with systematic disassembly. Teams of engineers took apart one B-29 in the exact reverse order that Boeing and its subcontractors had assembled it. Every single component was removed, photographed, weighed, measured, and analyzed. Draftsmen worked around the clock creating thousands of engineering drawings, each one requiring the crucial conversion from American measurement standards to the metric system used by Soviet industry. This alone was a monumental challenge. A fraction of an inch here, a slightly different thread pitch there, and the entire aircraft might fail catastrophically in flight. Tupolev assigned special teams to take responsibility for each and every element removed from the B-29. He mobilized scores of design bureaus, dozens of research institutes, and hundreds of factories across the Soviet Union. Their task was to create exact duplicates of the parts being removed and establish manufacturing facilities capable of producing them in quantity. Some suppliers lobbied to use their own products or manufacturing techniques, arguing that Soviet alternatives were just as good or even superior. Tupolev refused categorically. He demanded absolute conformance to the Boeing original, regardless of any perceived Soviet advantages. His reasoning was coldly pragmatic. Beyond the genuine technical risk that even small changes might cascade into catastrophic failures, Tupolev understood the political reality. Lavrenti Beria, the notorious chief of the NKVD, Stalin's secret police, was watching the project with predatory attention. If Beria perceived any deviation from Stalin's orders, however innocuous the engineering justification, he might interpret it as sabotage or treason. Engineers who made unauthorized changes might find themselves facing interrogation, torture, and death. In Stalin's Soviet Union, technical excellence was no defense against political suspicion. The electronic systems presented the most formidable challenge. The B-29's central fire control system used General Electric analog computers to aim and fire weapons remotely from pressurized compartments. This was necessary because the aircraft's pressurization system could not accommodate large apertures for traditional gun positions. The system was extraordinarily complex, requiring a host of intricate parts, precision switches, and sophisticated electronics that Soviet industry had never produced. But it was the radar that truly stunned Soviet engineers. When they finally understood what the AN/APQ-13 could do, the implications were staggering. This single system allowed American bombers to navigate and strike targets in conditions that would have grounded any Soviet aircraft. Night, fog, clouds, storms, none of it mattered. The radar could see through any darkness that nature presented. Soviet engineers had been working on radar technology, but nothing approaching this level of sophistication. The radar bombing system worked on principles that seemed almost magical to those encountering it for the first time. The rotating antenna beneath the fuselage transmitted pulses of radio energy toward the ground. Different surfaces reflected those pulses back at different intensities. Water appeared as dark areas on the display because it reflected energy away from the aircraft. Urban areas glowed brightly because buildings scattered energy in all directions, some of it returning to the receiver. Mountains, rivers, coastlines, industrial complexes, each painted a distinctive signature on the circular display in front of the radar operator. For Soviet engineers accustomed to the crude radar systems of their own air defense network, examining the B-29's equipment was like a medieval blacksmith being handed a precision Swiss watch. Every component revealed new mysteries. The magnetron that generated the radar pulses operated at frequencies and power levels Soviet industry could not reliably produce. The display systems required cathode ray tubes of exceptional quality and consistency. The associated computing elements that helped bombardiers calculate their release points involved electronic circuits of remarkable precision. The challenge was not merely understanding how these systems worked. The challenge was replicating them with Soviet materials, Soviet manufacturing techniques, Soviet quality control standards that had been devastated by years of war. German bombers had destroyed many of the Soviet Union's most advanced industrial facilities. Skilled workers had perished by the millions in the fighting or in the occupied territories. The factories that remained had been focused entirely on producing tanks, artillery, and fighters in massive quantities, with little attention to the kind of precision manufacturing that advanced electronics demanded. Yet Stalin's deadline allowed no excuses. Tupolev's teams worked with desperate intensity, sometimes literally around the clock, to solve each technical obstacle as it arose. The IFF system, the identification friend or foe transponder that prevented friendly forces from attacking their own aircraft, proved particularly problematic. Soviet intelligence had already managed to copy the American IFF system from earlier aircraft, but integrating it with the rest of the B-29's electronics required careful work to ensure compatibility. This brings us to one of the more absurd episodes in the entire reverse engineering saga. Through the Lend-Lease program, the Soviet Union had been receiving American B-25 bombers. By 1945, the B-25s arriving in the Soviet Union were equipped with radio receivers more advanced than those found on the B-29s that had crashed a year earlier. American technology had continued to advance, and newer aircraft carried newer equipment. It seemed obvious to Tupolev's engineers that the new Soviet bomber should be equipped with these better radio receivers rather than slavishly copying the older equipment from the B-29. The deputy minister of the Soviet electronics industry, Ivan Zubovich, agreed completely, but he refused to proceed without official approval from the Air Force representative, the renowned General Sergei Danilin. Danilin examined the newer radio receiver, agreed that it was exactly what the aircraft needed, and then declared that he could not give his official consent. This was the Stalinist system in miniature. Everyone agreed on the rational course of action. Everyone understood it would produce a better result. And everyone was too terrified of being accused of unauthorized deviation to actually make the decision. The insane logic of totalitarianism meant that the Soviet copy of the B-29 would include some components that were already obsolete by the time they entered production, simply because no one dared to approve an obvious improvement. The fire control system represented perhaps the most intensive effort. American engineers at General Electric had created something unprecedented, a computerized system that allowed a small number of gunners to control all of the bomber's defensive weapons from remote stations. A gunner looking through an optical sight could track an enemy fighter, and the analog computer would calculate the proper lead angle based on range, speed, and aircraft motion, then aim and fire the appropriate turret automatically. This system was vital to the B-29's design philosophy. The aircraft was pressurized to allow crews to operate at high altitudes without oxygen masks and heavy clothing. Large openings for traditional gun positions would have compromised that pressurization. The remote-controlled turrets solved the problem elegantly, but replicating them required Soviet industry to master entirely new manufacturing techniques. Soviet technicians disassembled the American fire control computers component by component. They traced every wire, identified every vacuum tube, measured every resistor. The precision required was extraordinary. These were analog devices where small variations in component values could throw off calculations significantly. A targeting computer that consistently aimed slightly behind a target would get Soviet bomber crews killed by enemy fighters. Factories across the Soviet Union retooled to produce the necessary components. Engineers who had never seen such sophisticated electronics taught themselves to manufacture them through trial and error, building prototype after prototype until they achieved acceptable quality. The human cost of this crash program can only be estimated. Workers pushed to exhaustion, engineers threatened with punishment if they failed to meet quotas, factory managers frantically cutting corners wherever they thought they could avoid detection. Then there is the famous story of the repair patch. One of the captured B-29s had taken battle damage at some point in its operational career. A hole in the wing skin had been patched with a repair plate, the kind of field repair that maintenance crews performed routinely on combat aircraft. When Soviet engineers disassembled this aircraft, they carefully documented the repair patch along with everything else. And when Soviet factories began producing their copies, some of the early aircraft included an identical repair patch on their wings, faithfully reproducing damage that had never occurred. This story has been told and retold, sometimes exaggerated, sometimes disputed. Some historians argue that Soviet engineers were certainly intelligent enough to distinguish between intentional design features and field repairs. Others suggest that in the atmosphere of terror surrounding the project, workers may have been afraid to omit anything, no matter how obviously accidental. Whether the repair patch story is literally true or an embellishment, it captures something essential about the mindset driving the program. Absolute fidelity to the original, regardless of logic or common sense. Subscribe now if you are learning something new, and let's continue this incredible story of Cold War technological espionage. By early 1947, the impossible had been achieved. The first Soviet copy of the B-29, designated the Tupolev Tu-4, rolled out of the factory. On May 19, 1947, Soviet test pilot N.S. Rybko lifted the Tu-4 into the sky for its maiden flight. The aircraft performed almost exactly like its American original. Soviet engineers had successfully cloned the most advanced bomber in the world. The first Western confirmation came at the Soviet Aviation Day parade in Moscow on August 3, 1947. Western military attachés watched with growing unease as aircraft after aircraft flew over the reviewing stands. When they spotted what appeared to be B-29s in the formation, some observers initially hoped these were simply the original captured aircraft being displayed. Then a Tu-70 passenger variant flew past, an aircraft that could only have been produced by manufacturing the B-29 design, and the terrible truth became clear. The Soviet Union now possessed the capability to strike the American heartland with nuclear weapons. The strategic implications were profound. American military planners had assumed they would enjoy a lengthy monopoly on nuclear-capable intercontinental bombers. The B-29's range allowed it to strike targets across the Soviet Union from bases in Western Europe or Alaska. Soviet bombers of indigenous design lacked the range and capability to retaliate effectively against the continental United States. This asymmetry had given American strategists confidence that they could deter Soviet aggression through the threat of nuclear annihilation without facing comparable risk to American cities. The Tu-4 shattered that assumption. While American intelligence had known that the Soviets captured the B-29s, few had believed that Soviet industry could actually reproduce such a sophisticated aircraft in such a short time. The technological gap that had seemed so reassuring suddenly looked far narrower. And in August 1949, the Soviet Union detonated its first atomic bomb, years earlier than Western intelligence had predicted. The combination of nuclear weapons and the Tu-4 meant that American cities now lay within reach of Soviet retaliation. The radar and electronics that Soviet engineers had so painstakingly copied played a crucial role in this new strategic reality. Without the AN/APQ-13 and its associated systems, the Tu-4 would have been a far less effective weapon. Soviet industry had struggled to produce reliable radar systems throughout the war, and indigenous designs remained plagued by quality and performance problems. The copied American systems gave Soviet bomber crews the same all-weather capability that had made the B-29 so devastating over Japan. Soviet engineers did make some modifications to the design. The defensive armament was upgraded from 12.5 caliber machine guns to 10 rapid-fire 23mm cannons, significantly increasing the aircraft's ability to fend off interceptors. Soviet engines were somewhat more powerful than the American Wright R-3350s, partly compensating for the slightly heavier Soviet structure. But the fundamental architecture, including the critical electronic systems, remained faithful copies of the American originals. The Tu-4 would go on to serve as the backbone of Soviet strategic aviation into the 1950s. 847 were produced, forming the Soviet Union's first true intercontinental nuclear strike force. These aircraft provided the deterrent capability that allowed Stalin and his successors to pursue aggressive policies in Europe and Asia without fear that the United States could attack Soviet territory with impunity. But the story does not end with simple imitation. The process of reverse engineering the B-29 forced Soviet industry to master technologies it had never previously attempted. The hundreds of factories and research institutes mobilized for the project emerged with new capabilities, new techniques, new understanding of advanced manufacturing. The radar and electronics expertise gained from copying American systems became the foundation for subsequent Soviet developments that would eventually produce indigenous designs matching or exceeding Western capabilities in certain areas. This was perhaps the most lasting legacy of the B-29 capture. Beyond the immediate strategic impact of the Tu-4 bomber, the reverse engineering effort accelerated Soviet technological development by years, perhaps decades. Engineers who had never seen advanced radar systems learned to build them by taking apart American examples. Factories that had never produced precision electronics developed the capability through forced crash programs. The institutional knowledge gained proved invaluable as Soviet military technology continued to evolve through the Cold War. The Americans, for their part, learned their own lessons. The ease with which the Soviets had acquired the B-29 technology through emergency landings highlighted the vulnerability of advanced systems to capture. Future American military programs would incorporate more extensive security measures to prevent sensitive technology from falling into enemy hands. The B-29 incident became a cautionary tale studied by intelligence professionals and aircraft designers alike. The radar systems that had so impressed Soviet engineers in 1944 continued to evolve rapidly. American bombers of the 1950s and beyond carried increasingly sophisticated electronics, staying ahead of the capabilities the Soviets had copied. But that initial technological transfer had demonstrated that no lead was permanent, that any advantage could be eroded by determined reverse engineering if the enemy obtained access to the actual hardware. For the American airmen who had made those emergency landings in Soviet territory, the full implications of their decisions would only become clear years later. They had faced impossible choices in the chaos of combat, selecting what seemed like the least bad option from a menu of terrible alternatives. None of them could have known that their crippled aircraft carried the seeds of Soviet strategic aviation, that the radar sets and fire control computers aboard their bombers would be dissected, copied, and turned against American interests in the emerging Cold War. The Cold War strategic balance that emerged in the late 1940s and persisted for decades was shaped in part by those emergency landings in 1944 and 45. The nuclear standoff between superpowers, the doctrine of mutual assured destruction, the arms race that consumed trillions of dollars and dominated global politics for half a century, all of it was influenced by the Soviet acquisition of the B-29 and its revolutionary technology. Today, the Tu-4 exists only in museums and photographs. The last examples were retired decades ago, their airframes worn out, their technology obsolete many times over. But the impact of the reverse engineering program echoes through history. Every subsequent Soviet and Russian bomber, every radar system, every piece of military electronics carries some trace of the knowledge gained from those captured American aircraft. The B-29's radar could indeed see through any night, as Soviet engineers discovered, to their amazement. It represented a leap in military technology that seemed almost supernatural to those encountering it for the first time. And when the Soviets admitted the capabilities of what they had captured, they also acknowledged the scale of the challenge they faced in matching American technological prowess. That they succeeded, however imperfectly, however costly the effort, demonstrated something important about the nature of technological competition. Secrets do not remain secret forever. Advantages erode. The gap between leader and follower can close with shocking speed when sufficient resources and motivation are applied. The B-29 story is ultimately a story about the diffusion of military technology, about the impossibility of maintaining permanent superiority through secrecy alone. For the engineers and workers who labored under impossible deadlines and constant threat of punishment, the successful completion of the 2-4 was a triumph of desperate determination. They had taken the most advanced aircraft in the world, stripped it to its components, understood its secrets, and rebuilt it from Soviet materials in Soviet factories using Soviet workers who had never seen such technology before. The human cost of that achievement, measured in exhaustion, fear, and lives destroyed by the Stalinist system that drove the program, can never be fully calculated. The radar set that could see through any night became a symbol of the technological gulf between American and Soviet capabilities at the end of World War II. Soviet engineers' frank admission of their amazement at its capabilities reflected an honest assessment of how far behind they had fallen during the war years. Their subsequent success in copying it reflected the remarkable adaptive capacity of Soviet industry when sufficient pressure was applied. If you have made it this far, you now understand one of the most remarkable technological heists in history. A desperate emergency landing delivered the future of Soviet strategic aviation directly into Stalin's hands. American radar technology that seemed like magic in 1944 was being manufactured in Soviet factories by 1947. The Cold War nuclear standoff that shaped the second half of the 20th century was built in part on the foundation of those captured B-29s and the engineers who worked under threat of death to unlock their secrets. Subscribe to this channel for more deep dives into military history, and share this video with anyone fascinated by the hidden stories of technological espionage that shaped our world. The B-29 radar that could see through any night changed history, not once but twice. First, when it gave American bombers unprecedented capability over Japan, and again when Soviet copies gave Stalin the tools to threaten American cities with nuclear annihilation. That radar set, captured on a remote Soviet airfield in 1944, cast its shadow across the entire Cold War era and beyond. July 1944. A crippled B-29 Superfortress, trailing smoke from its No. 3 engine, descends through the clouds over Vladivostok. The crew has just bombed targets in Manchuria, but battle damage and dwindling fuel have forced them toward the only neutral territory within reach, the Soviet Union.